boundary setup. So you can see COMSOL already provided me 50 individual electrodes. And this is required to extract the mutual capacitance matrix later on. And another boundary condition we want to implement is, of course, the ground. We already have some predefined boundary conditions, for example, for the ground plane, which is on the back of the glass substrate. And we will also introduce a second ground boundary condition for the stylus pen, which will then essentially emulate the condition when a person that stands on the ground is holding this pen, so basically the ground position and so on. For example, current distribution between those stitching wires themselves, so the load for some currents might be higher than the load for other currents, and this could lead to thermal or to degradation of that wire essentially and lead to failure. And the customer that was also working with this device and this analysis used COMSOL for analyzing how basically the placement of those stitching wires would impact the quality of these devices. And cross-sectional area of the core system here, we would then also extrude this in a 3D dimension. So you can see here already we're not simulating the individual turns of the coil. This will be a homogenized multi-turn coil domain later on for both the primary and the secondary coils. And we're also copying those coils to the top side. Next, we're going to model bobbins and the insulator parts. Those are basically the parts that keep the coils and the core in place and insulate those components against each other. We're also introducing work planes to define cross-sectional areas and then revolving those faces around a symmetry axis. And this would give us then basically the bobbins and the insulation domains.